In this video, we're going to talk about the ways the endocrine system is controlled. In doing so, we're going to also talk about negative feedback and positive feedback, and explain how the hypothalamus sort of controls everything. Because I was told in graduate school, always guess hypothalamus, so we better find out why. So, there's 3 methods of control, and this is just the overview slide. There's direct nervous stimulation. That means there's a neuron that goes somewhere and it tells a gland what to do. You also have another hormone affecting the endocrine gland. That's called a tropic hormone. And then just changes in blood iron level. About control, we have to look at the hypothalamus and find out why to always guess hypothalamus, even though I swear it was never one of the right answers. So the hypothalamus has nuclei. That would actually be the mammillary body right there. There's all these nuclei in the hypothalamus, and some of them are monitoring homeostasis. They're monitoring set points like body temperature, thirst, and so forth. Now, there's some axons from a couple of the nuclei, and those axons are going to go down from the hypothalamus all the way to the posterior pituitary. And they're going to release hormones. They're going to release 2 hormones, oxytocin and antidiuretic hormone. So antidiuretic hormone, let's say you're home, you are eating potato chips because you're studying. Those are really salty. It's going to mess up your water balance. So the body's going to actually make antidiuretic hormone, so you retain more water because you're eating all those potato chips. You really should snack on healthier food. This nuclei is going to release to the posterior pituitary, tell the posterior pituitary to release oxytocin during childbirth. Now, you have all these other nuclei over here, and they're watching various things as well. Now, instead of the axons going all the way down, they're going to release a hormone. Remember, a hormone is a messenger released into the blood to go somewhere else. The way the endocrine system is controlled is direct neural stimulation. You're driving down the freeway, going to school, you're already late, and somebody cuts you off. What is going to happen? Well, your heart rate's going to increase, your breathing rate's going to increase, your pupils will dilate. What kind of nerve response is that? It's a sympathetic response. Well, you have a gland called the adrenal gland. And in the adrenal medulla, you have a gigantic sympathetic ganglia. Remember the 3 options of the sympathetic nervous system once it leaves the spinal cord is to junction at the same level it left at, junction above or below the level of spine it left at, or go somewhere else without junctioning? Well, that's going to happen here. You have a sympathetic axon going, and it's going to these chromaffin cells in the medulla. And that axon is going to tell these cells to make epinephrine, or EPI. Now, epinephrine acts similar to the hormone, or the neurotransmitter. It speeds your heart rate, increases breathing rate. So, this is a case of direct neural stimulation. Another example, you're home, you're studying, you're eating a lot of potato chips and pretzels, all these salty foods you really shouldn't be eating. Well, that's going to make your blood really salty. It's going to raise the osmolarity. And we don't need to worry what osmolarity means. So the hypothalamus is going to detect this. And it's going to have axons going from a nuclei. And it's going to go down to the posterior pituitary. Axons going to the posterior pituitary. And what these are going to do is they're going to release a hormone called ADH, or antidiuretic hormone. And that's going to cause you to retain water because you already have all this salt. So those are 2 examples of direct neural stimulation. Here's a very busy slide with a lot of text. But basically, for neural stimulus, you have axons releasing into the blood. So here we have our axon leaving the central nervous system, going to the sympathetic ganglia, but not branching, going all the way to the adrenal medulla, and it's releasing epinephrine directly into the blood. Or we have down here the hypothalamus. We have axons going to the posterior pituitary, releasing either oxytocin during childbirth or antidiuretic hormone. So the hypothalamus actually makes several tropic hormones we won't worry about. And since the hypothalamus and all these nuclei in here are actually part of the nervous system, and they're going to release their hormones into the blood, that would all be direct neural stimulation for those tropic hormones. Now, a lot of control is by something called a tropic hormone. Now, tropic hormones are made by one gland, let's say the hypothalamus. We did TRH because you're cold. And that's going to travel by the blood to a distant target, like the pituitary. The pituitary is going to make TSH, which we will worry about in a few minutes, and that's going to go to the thyroid gland, and TSH stands for thyroid gland, or thyroid stimulating hormone. Guess what it does to the thyroid? That's right, it stimulates it. So the hypothalamus receives all this input from the nervous system, and it releases tropic hormones to control homeostasis. Now, the pituitary often releases its own tropic hormones. For the anterior pituitary, that's this part, there's 6 hormones. 4 of them are tropic only, and the other 2 have tropic effects. Now, changing blood levels of something like an ion, in this case calcium, or glucose, can actually directly cause the release of a hormone. So the parathyroid glands are these 4 pea-sized glands behind the thyroid gland. When there's low levels of calcium, the parathyroid glands, these things, detect those low levels and release parathyroid hormone, which will then increase blood calcium levels. The thyroid gland itself releases something called calcitonin. And that gets released if you have too much blood calcium. Now, you guys all know insulin. You eat a large meal, you're going to release insulin, which causes glucose and amino acids to be taken into body cells. And actually, both glucose levels, high glucose levels, or high blood amino acid levels will cause the release of glucose. So you have sodium and potassium causing an oxygen, causing another hormone. So you could have control. So on the test, I'll ask you what are methods of control of the endocrine system and what it means. Now, most hormones are controlled by something called negative feedback. And to discuss this, let's look at the temperature in your house or the classroom. It is set for 68 degrees. So, that is our temperature. Now, you are on your spin bike or your exercise bike, or you're running on your treadmill, or you're doing some sort of exercise in the room. The temperature in the room is going to go up to 72 degrees. That's a change in a set point. So, what's going to happen? The AC is going to go on and bring it back down. So we're now at 68 again. Well, you open all the windows and the air conditioner is still running. What is going to happen? Well, the house is going to get too cold. That's a change in the set point. So what's going to happen? That's right, the heater is going to heat it up. Now, notice, I didn't go past the original set points. Well, I sort of did. So there's my original set points. In negative feedback, there's a change. Detected. Messengers are released. Changes. And the set point is hopefully reestablished. Just see, I reestablished the set point. It stops at set point. Hormones rely on negative feedback. So the body detects a change from the set point, hormones are released, and it is going to continue until you reestablish the set point. So here's the example we've been talking about. You're cold. The hypothalamus makes TRH, again, we don't care what TRH stands for. That's going to send a tropic hormone to the anterior pituitary, which is going to make TSH, thyroid stimulating hormone, which is another tropic hormone. That stimulates the thyroid gland to make thyroxine, or thyroid hormone. High levels of thyroid hormone go back and they shut off production of the original two hormones, because if you keep making thyroid hormone, you'll keep getting hotter and hotter. Two hormones, prolactin and oxytocin, are controlled by positive feedback. So oxytocin does milk release, it's called the milk letdown reflex, and uterine contractions. So we have a baby. Here's our baby. Oops, that's supposed to be a mouth. And he's ready to be born. And here's the cervix, and let's make a nice dilated cervix. And his head is going to be pushing on the cervix. That's going to send messages. Which organ? Yes, the hypothalamus. And the hypothalamus is going to release oxytocin, because that's direct nervous control. Now, the oxytocin's going to go back, and it's going to tell the uterine muscles to contract. That pushes baby down more. That causes more stretching. More signals go to the hypothalamus. More oxytocin. More stretching. Or more pushing, more stretching. More signals to the hypothalamus. Until 12 hours later, we have a happy baby that somehow changed color during birth. Now, we're going to look at it in more detail in the reproductive system, but I might ask you which two hormones are controlled by positive feedback, and that's prolactin, which is milk production, and oxytocin, which is milk release and uterine contractions. Most hormones are controlled by positive feedback, negative feedback, feed forward, what is that? Don't know. Another name for steroid? No. So, there's only two. So it must be negative feedback, which is not a way hormones are controlled. Neural innervations, that's direct control. We've met three of them: EPI, oxytocin, and ADH. So, nope, that's a way it's controlled. Tropic hormones. So we did our TRH, because it's cold, causing TSH, because that's a tropic hormone, causing thyroid hormone. Those are two tropic hormones, so nope. Blood levels of a substance. Levels of the substance. Well, if you have high glucose, that causes insulin. And that's the direct response. You eat glucose, like, 100 grams of jelly beans for some reason. That's going to directly release insulin. So it must be cerebellum. Now on the test, I'd expect you to be able to explain these as well.